Welcome to this short video on how to complete a registration using Trimble RealWorks version 8.1. In this video I'm going to run through how to do an automatic registration, how to create or modify existing targets, and then how to register all the scans to a coordinate system. This RealWorks project already contains a number of imported scans. There are 8 of them, and these scans are either from a Faro Focus 3D scanner or a Trimble TX5 scanner. And I'm currently within the registration module. You'll notice that there is a blue colour to the station folder for each of these scans, and that indicates within RealWorks that their status is force leveled. In other words, the Z direction will be held fixed during any registration, so the scans aren't going to be pulled off vertical. Sometimes you may wish the scans to be pulled off vertical during the registration, in which case you can change the status of the scans so they aren't force leveled. But in this particular exercise it would make sense for them to be force leveled and to retain their vertical fixed orientation. So the first step in the registration process, I've got my folder selected, is to go to the registration menu and go to Auto Extract Targets and Register. Within this dialog you can specify by these tick boxes which targets the software should automatically search for and create, and just note that if you have sphere type targets within the scans, that the diameter of those spheres should be entered into this box here. It is possible to generate a preview scan, in other words a subsampled version of each scan during the automatic registration process. Particularly with small projects you may wish to do that. In this instance I'm going to leave that unticked and I'm going to create my own preview scan later. The reference station is important. This is the station which will be the starting point, if you like, and that will be fixed in position, and the other scans will register onto it. So depending on the geometry of the survey area, it might make sense to pick a scan which is fairly central. In this data set then I will pick scan 4 as it is fairly central to the whole scan area. With my parameters set, I hit OK, and the process will begin on each of the 8 scans to identify the targets within them. Okay, the registration is now complete, and I've skipped ahead in the video as the registration process on my computer took 5 minutes for these 8 scans. What we can see now is the registration details table, and within here we can see quite a lot as to what has happened within the registration. The registration table may initially appear in a basic mode, such as this, or if this advanced button has been ticked previously, it will show in its advanced format as shown. Essentially what we can see here is the overall residual error for the least squares adjustment of the targets within the project, which in this case is 1 mil. And you can see the residual error for each of the scans, and as I scroll down this table hopefully there will be 8 of them, and there are, which indicates all 8 scans have been registered. This RMS value is derived as a mean from the RMS values of the matched targets belonging to each scan. So perhaps if I start at the top of the table and look at the information in some of these columns. So starting on the left, we have the scan name, and below that we can see the targets that have been automatically extracted within each of the particular scans. And looking to the left of the name, you'll see a little symbol which indicates what type of target it is. So here we have a sphere target symbol, and down here we have a flat checkerboard style target symbol. Now each of these targets has been given a name, and the name has been automatically assigned so that it's a corresponding name. So where it's found a match of a target to another target within the project, a name has been automatically assigned which will match those targets together. So take for example here target which has been named 16. Its corresponding target name is also 16. And here in the next column we can see that there are 3 occurrences in the project of the target with corresponding name 16. So if we look down this table, we should find 2 other more instances of corresponding target 16. And sure enough, here we are in scan 2, and there is the second occurrence of target 16. And if we look down further to scan number 3, then here is the third occurrence of target 16. So for each of the targets that have been matched to targets in other scans, you'll see that the target name and the corresponding target name will be the same. Here in scan 2 I can see a couple of targets which have been named, but there is no corresponding target name. So in other words, these 2 particular targets haven't been matched to any other targets in the project, and so there is no corresponding information, number here, or any residual information. Going back to the top of the table then, looking across to the remaining columns, we have the residual error. So this is the distance error in fit for the position of scan 16, target 16 in scan 1 versus the corresponding position of target 16 in scans 2 and 3. And we can see there's approximately a 1 mil difference, which can be broken down into X, Y and Z. And we can see that that 1 mil is largely derived from a disparity in the X direction. The fitting error is the amount of discrepancy between the fitted spherical shape to the points that have been used to define that shape. In other words, how well that spherical target has been extracted from the cloud. And here we can see in the last column the distance from each particular target to the scan center or the scan position. So target 16 in scan 1 was 6.163 meters from the scanner. So it's a good idea, as soon as this table appears, to A, check that all the scans have been registered, and indeed you'll see an unmatched station tab appear here if some of the scans haven't been registered. B, you can then look down the residual error column and look for any high residuals. Most should be several millimeters at worst, but it does depend upon the nature of the scan and the environment. But if you do see a target which you suspect, it's possible to go and analyze that target in more detail later. Additional information can be revealed by clicking on the scan name as shown below, and also on the individual targets. So far with this dataset, everything appears reasonable, at least looking at the table of match results and the residuals that correspond to the matched targets. Close up the table and look over at the target base registration dialog on the left. I can see that it's using, as I requested, scan number 4 as the reference scan, or in other words the reference station, and that same scan is shown in bold text here. What we can also see in this table for all of the 8 scans is the number of targets extracted in each of the scans, which is the second number here, and the first number that precedes it is the number of those targets which have been matched to targets in other scans within the project. And then we can see our residual error summary for each of the scans as well, as we saw in the table a moment ago. So at this stage you may just want to continue and finish the registration process, or if you wish to analyze some of the targets in more detail, perhaps you suspect that they're erroneous or they haven't been fitted terribly well to the scan data, or you may suspect that targets have been missed, you can go to step 2, which is to create or edit the targets. So I'm going to do that and press the Analyze button. This then gives me the Target Analyzer tool, and within step 1 of that tool I have the reference scan picked, scan 4, and using the arrows it's possible to move through the project to inspect each of the scans individually. When you browse to a particular scan, in step 2 you can see all the, in this case, automatically extracted targets that exist for that scan. If I pick a particular target, here we are with 16 again, it would be possible to reselect a part of the cloud to fit that target too, or to use the red cross here to delete that target from the project. Over on the right hand side we can see an image style overview of the scan, into which you can zoom and pan by using the roller on the mouse and the left mouse button to pan, and below that again we can zoom and rotate and see the part of the scan which the target has been fitted to. Now with this particular data set, if I scroll across to the right and zoom in, I can see there's a target over here, a sphere which has been missed. So I want to extract that and bring it into the project. So I'll go to step 3, press extract, and a target creator tool appears. Within the tool you have a number of options about the type of target you might want to create. Spherical, black and white, checkerboard type target, a flat target, or an arbitrary point to be used as a target. In this case I want a spherical target, and I have two methods of extracting that target. I can use a single point click, or I can define my own window around the scan data that contains the target. Again, checking that the diameter of the target is shown in the corresponding box. So I'm going to use the single point click method, and I need to click then onto the target I wish to extract. RealWorks will extract a portion of scan data around the target and fit the spherical object to it, and I can zoom in and take a look at how good that fit is. Looks pretty good. I get some fitting residual information over here on the right, which is 1 mil. If I'm happy with the results, I press create, and then the little door symbol to close the target creator tool. And I now have a new spherical target created in this project called Target 71. So if I wish to, I could proceed through the remaining scans, perhaps modifying targets, deleting some if necessary, or creating any new targets that I need. That's all I'm going to do for the moment in terms of target editing. But what I do want to do is to update the network, because I've added a new target to it, and I can do that in step 4. I press adjust, and it says some targets have been created or modified. Do you want to do an auto match station? And an auto match station will attempt to take all the targets in the currently selected scan or station and try to rematch them to the other targets in the project. So I'll say yes and see what happens. Well, the registration details table will appear, and I can see here in scan 2 target 71 has been given a matching or corresponding target name of 10. And when I look into the next column, I can see that corresponding target 10 occurs 5 times within the project. So it occurs here in scan 2, and straight away I can see here in scan 3 it also occurs. And if I was to scroll further down, yep, here in scan 4 we can see it occurring again. And indeed, by clicking on it, I can see exactly which scans the target with corresponding target ID 10 appears in. Okay, so I've added that new target into the mix. I can close my table, press apply, assuming I don't want to do any more target editing, and it takes me back to the main target-based registration dialog. I'm just going to do a final adjustment here in step 3. Okay, nothing should have changed. Close the table, press apply, and then group. So what will have happened is that all the scans will have been registered together based on those matching targets, and now all of those scans have been placed together in a new group folder. If I click on the parent project name, in my list window down here I can click on that group folder and press F2, and I can rename the folder itself. If I now zoom out, In the 3D view window, I can see all of the targets that have been created during the registration process so far. One thing I like to do is within the list window here, right click on one of the scans, which produces a menu, and on the menu is display or hide network visuals for a selected station, in other words the currently selected station, or all the stations. So I'm going to go for all the stations. Green lines then appear on the screen which interconnect the match stations to the scan positions within the project. So again, I'm getting a feel for whether all the targets have been matched, and here I can see one which hasn't been matched. I can see those that have been matched to other targets. This one, for example, here with matching target ID 11, I can see quite clearly is matched to, or exists within, scan number 4, scan number 5, and scan number 7. And if I view from above, I can have a look at the overall geometry of the targets. So we want a decent geometry, well spaced out targets within the project. If we don't have well spaced out targets both horizontally and vertically within the project, then we can hardly expect the registration to be particularly good. So target registration is key. So far so good. I don't as yet though have a preview scan to do any more visual checks on the registration. So that's what I'll proceed to create next. So with my project name selected again, I go to the Tools menu and I want to generate a key plan from TZF scans. So in other words, it's going to create an overview image, if you like, of the scans in a plan view. It means that when I go into the Scan Explorer, which is the yellow button here, it's prompting me that I need to save the project now, which yes, I will do. When that Scan Explorer appears, I can look around each of the individual scans, but what I want to do is click on the Key Plan tab and bring the view so that I can see my plan view image of each of the scan positions relative to each other. To extract points into RealWorks from Scan Explorer, I can click on the extraction button. With 2 clicks, I can place a window over the scan data, specify the subsampling resolution that I want for my preview scan, and then I can hit the Create button to extract those points into the main RealWorks interface. And depending on the number of scans and the degree of subsampling that you've requested, that process may just take a minute or so. Okay, so the extraction is complete. I'll now close or minimize the Scan Explorer dialog, and now I can see my points comprising my preview scan, my 50mm subsampled scan. And there's a bit of an extra check on the registration before proceeding any further. What I like to do is to use the cutting plane tool to slice through the scan data to get a better visual impression of how good the registration is. So to do that, I'm going to leave the registration module temporarily and go to the Office Survey part of RealWorks. Here I can see Object 1, this is my subsampled 50mm preview cloud. I'm going to click the light bulb to display it. I'm going to zoom extents, and I'm going to launch the cutting plane tool once I've selected the cloud. Cutting plane tool is activated using the red and yellow striped cloud symbol here. Like many of the RealWorks tools, it opens over the workspace window. And I wish to initially perhaps slice through the cloud to create a section. So I'm going to use the plane perpendicular to screen option to position my cutting plane through the data. I'm just going to redo that. There we go. Z is now pointing up in this lower half of the screen, this 2D view through the data. If I zoom in a bit here, I can align the scan data to the grid lines, and I'm now looking through, if I rotate this around, a cutting plane or a slice or a section through the cloud at this particular position. And I'm checking that data from different scans, as will be shown in different point colours, is fitting together properly and isn't offset in any direction, and I can zoom in if needs be to check that in more detail. Okay, clicking and holding on this blue slider here and moving the mouse, I can slide the cutting plane through the data and just maintain that visual check as I push through that the scans do fit together in a way that I would expect them to, and that they aren't skewed one against the other, and that we have different coloured points overlaying as would be expected where you have data from multiple scans within the same section. So far looks okay. Now I want to look in the Z axis direction. So I'm cutting through the side of this building now, if you like. And again, I can move that cutting plane or that slice up and down through the data to check that it fits together properly, and I can zoom in again if needs be into a particularly critical area just to check that everything is as I expect it to be. Okay, so yes, that all looks square, nothing looks skew with or positioned at a strange angle. That floor plan looks okay. So I'm going to close the tool, visual check complete, and go back to the registration module or part of RealWorks. Now, at this stage, the scans appear to be registered together well, but they form just a local registration. In other words, they're not registered to an external coordinate system. Now I do have 4 points in a coordinate system for targets within this project. So my next job is to register this data to fit that coordinate system. There's a couple of ways we could go about that. There's a manual way using the georeferencing tool, or we can use an automatic matching method for RealWorks to find the corresponding targets in the locally registered dataset with the coordinates that are going to be imported from a text file. So let's start by bringing in the text file with the coordinates in. So I'm going to go to the Open button and check that the file of type filter is set to Survey Network ASCII files, and click on my text file containing the point coordinates and open. And I need to check that the import option is set to as a topo station. So in other words, it's going to create topo points which will be used subsequently as targets. I don't need to skip any lines within the text file, it only contains the coordinates. But I do need to check that the separator is specified correctly, and for this text file, comma is correct, and I can see that the values are separated out nicely. I need to check the units is correct, yes, meters is selected, and I need to check the coordinate sequence is correct as well. And in this instance, yep, point ID XYZ is the correct coordinate order. It's correct for the UK and Ireland certainly. In other parts of the world, maybe you have a Northings First coordinate system and you would go for this option. I need to pick this option. Everything looks okay in the preview, so I press OK. See now that we have a new folder appear in the list window, which corresponds to the name of the text file the coordinates were in, and the 3D view is now suddenly quite different because the coordinates in the text file are positioned hundreds of meters from the locally registered points in the scan data. That's normal. Next thing, I will pick the 2 folders containing the scan information and proceed to perform the automatic registration. So go to registration, target-based registration tool, the registration takes place, and now the imported coordinates are included within the registration. So here we can see point ID with 201 has a corresponding ID of 8, and this target occurs 3 times in the project. So here it is in scan 1, well in the coordinate folder. And if we look down the table, check for another occurrence of ID 8. Here it is in scan 5, and there should be one more occurrence, and here it is again in scan 6. So we can see that there aren't any residuals here for these points because they're considered as the fixed control, and the targets in the scans have been fitted to them. So it's the targets in the scans that will show any residual fit in the errors, not these targets here. So if we take 8 as an example and scroll back down to scan 5 and 6, we can see any residual fit error of scan 8, of target 8 in scan 5 to that coordinate, and yes, we've got some small residual fit error to it. And if we look here at scan 6 for corresponding target 8, again we've got some fit error as well to that imported survey coordinate. But our overall residual error is still small, and none of those fitting errors and residual errors appear large. So everything's okay. I'll close the dialog, press apply, and that will now move the locally registered cloud onto the imported coordinates. Once that's done, I'll press group, and again that will create a new folder, default name of new group, and if I double click to browse into that folder, I can see the 2 child folders which belong to it, one containing the imported coordinates and the other containing the scans. And if I zoom extents now and zoom in, there's the data set registered to the imported coordinates. If I turn off the cloud for the time being, here I can see the position of those imported coordinates and the stations that they are connected to, the scan stations they are connected to. Okay, let's pop the cloud back on. So, just about finished. I just want to check for peace of mind that the coordinate system now looks correct. So using the measurement tool, check that the measurement mode is set to XYZ, click on a point, and I can see by the long coordinate number values here that I'm now in the working in the coordinate system of the imported coordinates and no longer in a local scan based coordinate system. So I'm going to leave the tool, save the project, and for record keeping purposes I'm going to click on the project name. From the registration menu, select registration report, pick a folder to save it in, give it a name, and a registration report in RTF text format will be created, showing the same information essentially as was shown in the registration details table which we were inspecting earlier. So there's the information for the imported coordinates, no residual errors, match target names, number of corresponding targets, and then the residual errors for the targets within each of the scans. Thanks for watching this video. hope it was useful. If you have any questions, please feel free to contact me on the email address shown in the slide.